You don't have to go physically visit each one of those boxes in a manufacturing floor or a conveyor or warehouse. You can now virtualize that workload in a VPLC.
Yeah, actually, maybe I could pause there. I didn't see everybody.
There's a feedback from me, maybe.
Raise their hands, but any of you are familiar or know what a PLC is? Oh, great, awesome. Yeah,
that's a good representation.
I think when we say that, it's actually it's a very tall task, right? To be able to virtualize a PLC and then be able to support some of those OT protocols like Profinet, and that are, they are Ethernet based, but they don't really, use, let's say, the TCP stack to communicate with each other, right? So you're talking about Profinet support to be able to support these virtual PLCs, moving from a physical PLC to a virtual PLC and vSphere. vSwitch, in that case, right, needs to be able to support Profinet, has to be able to process those packets very quickly. In certain cases, safety PLCs have, latency requirements, like jitter requirements of under 250 microseconds in some of the use cases that we've spoken with customers with some of you here, actually. And so, we'll go into a little bit about that in the use case section, where we're going to talk about, okay, how are we adding the Profinet support to the vSwitch, and then how we're also adding things like PRP, parallel redundancy protocol, that needs to be supported to support those very stringent high latency use cases.
Shameless plug, by the way, on this slide. All these workloads that we've mentioned here, you can see them live in action in the innovation zone if you're curious. If you've got computer vision or you've got the PLC use case, you can stop by the innovation zone and see that stuff in action.
Yep.
Okay, so we're going to get into the architecture overview.
Yeah, so these are really the 6 pillars that we want to go after. So if you look at Edge Runtime, it's about basically supporting runtime for both containers and VMs, and actually shrinking that down, if you will, let's say from a TKG perspective, to be able to support Kubernetes at the edge. For pull-based orchestration, we'll actually go into a few slides on the VMware Edge Cloud Orchestrator, which essentially uses a pull model to initially bring up the, let's say, a vSphere cluster, because traditionally, right, when you want to bring up a different host in a cluster somewhere, actually it has to be, you need to have bidirectional non-NATiC connectivity between your edge site and your vCenter, and it's usually the vCenter reaching out, right, to connect to your vSphere host after you've already set things up. What we want to do with the VMware Edge Cloud Orchestrator, or VECO to be short, is that we want it to be deployed with zero touch or minimal touch deployment, meaning that we're going to have a edge client software that's going to be part of the VIB as you bring up a vSphere host, and then have it reach out to the cloud to be able to configure itself, and then bring itself up, as opposed to the opposite direction where you actually need non-NATiC bidirectional connectivity up, right? And we'll go into that a little bit, and Mike will also talk a little bit about how we're actually leveraging the KEZIC project to be able to do that for the ECS clusters.
We'll define what Project KEZIC is in a later slide.
Yeah, of course.
Hold that point.
So these days, can't talk about any platform or services without talking about security, and so these include things like VM encryption and that aspect. And then in the future, we're going to be working on an AI platform, also a data platform, leveraging existing VMware products or projects. And then last but not least is services platform. And what we mean by that is, how by using the VECO, VMware Edge Cloud Orchestrator that we were just talking about, be able to overlay services on top of the Edge Compute Stack. So leveraging SASE for network connectivity between sites that might not have private connectivity together, and also things like private 5G, right, for connectivity as well. Okay. Okay, so at a very high level, we want to have an edge compute stack, or you want to have an edge compute stack because you want a single consolidated platform, right, to be able to run your existing applications that might be on a VM, and then also like containerized applications that in the future you might be looking at 5 years down the road, and you want something that where it doesn't matter whether these VMs, are just for standard web applications, or they're for, these real-time applications that we're going to talk a little bit about on the OT side. They can all run together in a single platform, and meaning that, okay, let's say I need a VM that has to be able to support the Profinet application, the virtual PLC that we talked about. Instead of you having to do a bunch of customizations in your VMX file, we're going to enable, let's say, a set of feature sets to automatically enable high latency sensitivity for that VPLC VM, reserve the memory and CPU cores dedicated for that specific virtual PLC, right? So you want to have a whole platform that can do all that automatically, along with containerized applications supporting Kubernetes at the edge as well. And I think the rest of the reason for Edge Compute Stack aligns with core VMware values, right? So have a consistent platform, consolidate where you can, and then obviously have an open platform, and then support security along every stack or every layer of the stack. So now we're going to talk a little bit about the VeCo, like I mentioned. So this is a roadmap item that we've been working on, and I know that some of you here, we actually talked to you during CTAB I think it was a few months ago, right? And we got some feedbacks on what you want. So initially, we were going to develop the VMware Edge Cloud Orchestrator just for provisioning and deployment of vSphere clusters, but then the feedback we heard was, well, we want a lot more than that. We want you to be able to do lifecycle management. We want you to be able to deploy, let's just say, VMs for inferencing, right, for AI ML. And so from there, now it is going to be essentially an orchestrator of orchestrators, if you will. So with VeCo, you can have a SD-WAN orchestrator as essentially a service on there, along with private 5G, as well as Edge Compute Stack. Okay, so we talked about a little bit earlier on this is, why do you need this in Edge Compute Stack? And the main reason is that with Edge Compute, with your edge sites, it's more than just 10 sites that you want to manage, right? So in some retail use cases or manufacturing use cases, you might have lots of different stores, and in manufacturing, you may have lots of different lines where you may have a vSphere cluster running that are managing those applications that are meant for that specific production line. So you have many different sites that you need to manage over time. And so here we're basically saying, okay, if you are looking at a greenfield deployment, a site that you're bringing up, or maybe hundreds of sites that you want to deploy apps on, from there you can have enable the edge client inside of the VIB, right? Like I mentioned before, it can be shipped from the factory, or you can do it straight from bare metal. So from there, you would deploy EXXI on it. The EXXI image is going to include the edge client. The edge client is going to leverage the TPM chip on there to authenticate once it reaches outbound to the VMware Edge Cloud Orchestrator. And then from there, bring itself up, right? And so that connectivity can be over the internet instead of having a private connectivity ahead of time to bring that vSphere cluster up. The second option down in the bottom there is where we're going to leverage the Keswick project. And so Mike will actually go into a little more detail in that next slide. But from there, what we also want to do with the Edge Orchestrator is that the ability for you to bring up the Kubernetes infrastructure at the edge as well. So, when you bring that up, instead of having someone to manually having to create the workload cluster at the edge from the management cluster, we're going to build automations allow you to automatically bring up however many workload clusters you need at that specific edge site and have it automated. And then in the future, it's going to allow you to set up additional services, right? That might include ENI, and ENI is something we'll cover in a little bit as well, is for basically monitoring of your applications and network latency measurements, also some of the networking kind of anomalies it's able to detect at the edge sites. So it's, in the future we'll be able to bring those services and then also do life cycle management of existing vSphere clusters, right? Rather than just be able to bring up new edge sites. Okay.
Yep. Yeah. So, like Ken was mentioning, the KESWICK project, KESWICK, pronounced KESWICK. That's the code word for an R&D project that was started a couple of years ago within our R&D department, and it was focused on GitOps deployment, GitOps enabling a small form factor edge device so that it can bootstrap itself with small Kubernetes and deploy apps automatically. So in the traditional ESX, and you might have heard of TKG, Tanzu Kubernetes Grid, we're going to talk about that later, the process is very from vCenter. It's driven from vCenter, so we deploy the ESX host, we configure the ESX host from vCenter. Yes, there's APIs on vCenter that you can automate those things, but it's all through the lens of automation through vCenter. KESWICK is taking that model and basically rearranging it so that it's all driven from Git. So when we bring up, in combination with Vico, the Edge Cloud Orchestrator, we bring up the hosts with Vico, and then we bring up Kubernetes with this GitOps approach. The host knows where the GitOps repo is, and it knows what I want deployed there. It wants a worker or two workers of Kubernetes. It wants these apps deployed, and it wants access to this type of GPU. That's all defined in a Git repo, and so when the host and the environment comes up at a remote site, it goes and retrieves that intended state from Git and brings itself up. So you can see some of that stuff in action in the innovation zone. There are also separate sessions just on Project KESWICK. But the service provider and Edge business unit of VMware will be working on bringing those things together, VMware Edge Cloud Orchestrator and Project KESWICK. That's mainly what we're talking about there. So if you do have small form factor devices that are not traditionally on the ESXi hardware compatibility list, come talk to us, because that's sort of the area that Project KESWICK is going to be focused on first. And then, of course, expand into data center class servers that we run at the edge. But I am personally more focused on the small devices within our edge team, and obviously KESWICK is an important part of that. Okay.
Right. So what we want eventually is, right, this kind of type of workflow for your new edge sites. And so basically you want the device to be shipped to the site, and instead of you having to bring it to your warehouse, get your folks to set up every host on there, deploy the VMs and so forth, or containers on there as needed. We want this workflow to be that you can predefine your configurations, right, for these different edge sites ahead of time inside of the Edge Orchestrator. You ship your 3-node cluster, 2-node cluster, single node cluster on site, and then it's going to, it's like I said, it's going to have that Edge client that's built in within the image, and it's going to come up, grab an IP address via DHCP, or maybe you need it to be statically configured. It's going to come up, talk to the Edge Orchestrator, grab its configurations, and then basically say, okay, these are the networks I need to set up in the distributed vSwitch. These are the different Kubernetes workload clusters I need to bring up, so forth, right? All of that is defined within either the Edge Orchestrator or a Git repo. So, And from there, you ship it on site, someone plugs it in, and it'll automatically come up and do all the things I just mentioned there. Okay, so now we're going to kind of get into the technical nitty-gritty details of the solution itself, and then talk about the different components, talk about networking in the next section, and then also Mike is going to follow up with the different edge apps, right? The deploying edge apps at the edge. So these are different components that are part of the Edge Compute Stack. I think most of this should be fairly familiar to you. So you have the vCenter, right, which is managing all of the vSphere clusters. And then you have TKG and TMC for management of the Kubernetes clusters. And then there's an ENI, which is also part of the Edge Compute Stack, and it's there for providing network insights and providing performance monitoring and also troubleshooting, more leaning towards the networking aspect of things. So it's able to, what you do is you would span your networks at the edge, and the edge, the ENI it's a VM that's running on there, and you can span your networks at the edge and send all that traffic to the ENI. We call it a qualler, and then the qualler will sift through that data and then send the necessary metadata to the cloud for monitoring actionable steps and so forth.
And ENI stands for Edge Network Insights. Okay.
Or Edge Network Intelligence.
Intelligence, right. Keep us straight.
Right, so here's the architecture overview of what a typical Edge Compute Stack deployment would look like, right? And I know the data center side is driven very wide. It doesn't mean that it's going to be as big as it may seem, right, in this slide. But essentially, you have different vCenters that are on the data center side. We recommend that you have your standing data center vCenter that are managing your existing workloads and your existing infrastructure in the data center, but then set up a different vCenter to manage your edge clusters. And then that's also, you would want to set up a different TKG management cluster to manage those edge workload clusters as well.
And by the way, if you're not familiar with TKG, Tanzu Kubernetes Grid, that's our GA available Kubernetes distribution today that runs on vSphere. It has a component called the management cluster that's responsible for lifecycle managing the edge Kubernetes workload clusters. So that goes hand in hand with vCenter in the data center. So for each vCenter, you're going to have a TKG management cluster to deploy Kubernetes if you optionally want Kubernetes at the edge. If it's just VMs, of course you don't need TKG then.
So in the bottom there, we're basically showing the different types of edge sites. So they can be, typically, at least they can be a single node or two node or a 3-node cluster. And you would run your TKG workload cluster there along with a local a harbor if that's needed. And then for those edge sites, they will talk to multiple SaaS components as well. So they're going to talk to the SD-WAN orchestrator if you need to have WAN connectivity from your edge sites to your data center, and leverage SD-WAN to have essentially a full mesh private connectivity between your sites. And then they also need to talk to the TMC, talk to TMC in the cloud as well, and then also for ARIA for application operations if needed. So.
And it might be subtle in this slide, and we'll talk about this maybe in some other slides too, but we often get the question of how much resources does your edge need? Can we fit it on a single host? How big is your Kubernetes? That's a common question. It can get down to as small as a single host. You can have Kubernetes as small as a single VM. And so the size of that VM, CPU, and memory is going to be driven mostly by your apps. So when we get this question of how small can you make your Kubernetes, it's really a question of, how many apps do you have to run there and what's your HA requirement? Can you run a single node? can you put it all in one VM and handle a case when that one host goes down? Then we can make that pretty small. If you need HA, we're going to go further to the right. And we're going to increase the size, the number of hosts and also the size of the Kubernetes footprint. So anyway, just want to make a point of that because it's often a question we get about the Kubernetes component. How small can you go?
And then there's also the use of shared witness nodes in the data center. So if you have your edge sites, let's say two node clusters at edge, and then you don't have another small server to set up a witness locally at that site, you can also leverage shared witness nodes that are in the data center as well. So there's plenty of sizing guides for that, and so the largest witness node in shared witness node in the data center can support up to 64 vSphere clusters, for example. So, okay.
Yeah, and just go back to the previous slide real quick before I talk about this one. Sure. So Ken mentioned these SaaS components. Obviously, these SaaS components they're optional. So when you use ECS, you have the option of using these components. Tanzu Mission Control is for lifecycle managing the fleet of Kubernetes. So you'd use that in connection with vCenters that you run in your data center. But sometimes we have a lot of customers that say we can't have connectivity out to a SaaS interface of any sort. It's completely air-gapped, it's private networking only. And so how do we answer when it's just a private, on-prem solution architecture? So we introduced last year, you see tons of Mission Control now shifted to the corporate data center. We now have the option to do a self-managed, basically install Mission Control yourself and manage the fleet of Kubernetes in your on-prem infrastructure. And you can choose where to deploy that. It could be, one per edge site. If you've got a factory that's got many clusters, you could have Mission Control could actually run at the edge site. Typically, we'll see this deployed in one central place in the data center and manage those components that are out at the edge site, the Kubernetes components at the edge site. If we don't have ARIA operations for applications, which is formerly Tanzu Observability, which was formerly Wavefront, it's been renamed to ARIA operations for apps. We move that into the data center, and it comes in the form of pretty much the ARIA operations suite. If you need to have just only on-prem observability solutions. And of course, those things are optional as well. You can hook up to whatever logging infrastructure you have instead of using ARIA. But just wanted to point out the main thing here is that we got a lot of requests for a non-SaaSified edge answer, and that's what this is.
All right, just very quickly, this is just summarizing your at the edge, right? The different options. So you can have a single node, or you can have multiple nodes using vSAN, and then run your VMs and Kubernetes on top of that. And so we're just pointing out in this case the different what you lose, pros and cons of the two different approaches. And I think Michael.
Yeah, there's a little bit more details about the trade-offs. If you have a single physical host problem to solve and you've got apps that have important business data on it, the best you can do there is automate for sort of an edge repave in the case of a failure. In other words, if I have a failure, have it fully automated so that I can just repave that single node device and protect the data as best you can with some sort of store and forward technology. We use RabbitMQ streams, but of course there's lots of approaches to doing that. But you can achieve edge and have a certain amount of protection with even a single host in our architecture. When you get to two hosts, I call that the run flat. You can withstand some failure situations for a period of time, but not all of them. And then if you really wanted full HA redundancy, if a host goes down, you still want apps to deliver and data to be protected. You really are talking about a 3-node setup. Even data services that you might want to run in VMs or containers, a lot of them these days are quorum-based. They have a clustered technology, and it's got to be an odd number. And if you only have 2 physical hosts, and one of those hosts goes down, has 2 of those instances of that cluster-based data service or database, you don't have your HA anyway. So you got to, if you really want HA, you got full HA, zero downtime, and zero downtime patching. You got to get to like this the model of 3 approach. But anyway, the point of this slide is that you can make the decisions based on how much pain you can incur if a physical host goes down, and then spend accordingly.
Yeah, so it's a big decision point because typically you're not talking about 10, 20 sites, right? In most of your deployments, you could be looking at hundreds of stores or potentially up thousands of locations.
Yeah, you can just play this one all the way through.
Sure.
Oh, yeah, one more. There we go. Okay, so in the Tanzu branding, there is Tanzu Kubernetes operations. And so within that, there are components that we use in the Edge Compute Stack. And just to make it clear, Tanzu Mission Control is the fleet management. You have the option of using NSX. NSX is also included with ECS. NSX we find for what I jokingly refer to as mini data center edge, because it is a full-blown load balancing technology that has control plane VMs and service edge VMs. When it comes to lighter weight edge deployments, we have alternative options for Kubernetes in-cluster load balancing. A lot of people like Metal LB, so that's absolutely supported as well. So for a small edge site, you would not use VMware NSX. And then, of course, vSphere and TKG are part of that as well. Some of the other optional add-ons, service mesh, that's sometimes a use case we hear with Edge. We don't hear it quite often, though. The ability to have an Istio-based service mesh that apps running at the edge can discover apps that are running elsewhere, potentially in data center or in cloud, and look at them as if they're in the same environment. That's kind of what service mesh does for you. Allows you to bring those microservices together. Okay, so ARIA operations for applications. It's kind of a mouthful. It used to be Tanzu Observability. This is a SaaS-based environment for capturing observability metrics from just about everything. It could be vSphere, it could be Kubernetes, it could be your apps, Spring, RabbitMQ, cloud providers, Edge, the whole thing, the whole 9 yards. And the main premise of this technology is to do the smart correlation. It's basically an 18-month time series database as a service for you with smart intelligent dashboards on top of it. So it is a pretty powerful add to the Edge fleet if you wanted to bring all that data together somewhere and see correlation of data across all the components in the Edge. Okay, so yeah, further into the observability, it allows the ingestion of data points from a wide variety of technologies. It does automatic analysis, so the trending analysis and things like that. It also allows you to define actions, whether those actions be from alerts to emails to webhooks calling out to other interfaces. And you can tailor it to different audiences depending on what level of the organization they're responsible for. There's a network view, or there's an infrastructure view, or there's a business view of the application. You can create your own custom dashboards that kind of tailor to those different personas. And so mission control, to go deeper into mission control, it does support the lifecycle management of the clusters, but it also supports things like security policy control. And having consistent, if you've got 1,000 of edge deployments and you want the same consistent Kubernetes security policies applied across those thousands of edge sites, mission control gives you that single pane of glass to manage that. Run conformance tests and do some high-level observability on the clusters. The cool thing about mission control is you can organize your clusters into groups. So let's say, for example, you're a retailer and you've got thousands of edge sites. Typically, you'd want to create a group out of stores that are located close to headquarters and call that your canary group. And so that you can define GitOps processes from a group within Tanzu Mission Control that says, when this particular branch of a Git repo, GitOps repo, gets updated, only roll it out to that group of clusters first, and then roll it out accordingly to other sets of clusters over time. So it gives you a way to organize a high volume of edge Kubernetes environments and then manage the GitOps and security policies that you're going to apply to those in one place.
All right, so now we're going to jump back into infrastructure and details on how to set up vSAN kind of networking at the edge. So I guess raise of hands, like how many of you have set up vSAN from scratch, right? So essentially you got a couple hosts or 3 hosts set up.
There was about 10 maybe.
Okay, good. And how many of you have used like a local vSAN witness or a remote vSAN witness here? Oh, there's a few raised hands. Okay.
So you got some experience with a remote witness.
All right. So I'm glad it's not everybody that raised their hands, because I do plan to stop on a slide for 5 minutes to talk about local vSAN witness design. So it's good news. So this is sort of a reference architecture for what a small edge compute stack deployment would look like, from a data center to the edges. And SD-WAN in this case is completely optional. It's actually an add-on to ECS. And so you can deploy maybe a SD-WAN physical device that's in front of the edge compute stack cluster, or have it run as a VNF or a VM inside of each of the hosts. And then from there, right, you can run your typical applications, either they're in a VM format, or if they're running on TKG, on the in a workload cluster, which would typically consist of a control plane VM and a worker VM, right? On the host, you might have, if you require a bigger footprint, you may have multiple worker VMs that are on the same host, right? And then for the cloud portion, you would have a SD-WAN orchestrator that's going to manage the SD-WAN instances that are running on the host in the cluster. And then also you're going to have a TMC, unless it's air-gapped, right? That's going to be a SaaS component managing the Kubernetes clusters. So I think, earlier, you're like, oh, what is this ENI, Edge Network Intelligence? And, to put it in a very simple way, it's essentially a VM that you can deploy in either a single node or a vSphere cluster. It's going to leverage VDS to be able to basically span all of the data that are going out of the cluster or a single host to this specific VM, and then the ENI crawler will ingest all of that data and then consolidate what it found in metadata, and then send it to the cloud for analytics or alerts and so forth. It does require VDS or vSphere distributed switch. So if you're using a standard switch, it won't work because port mirroring or span is only enabled in VDS. Additionally, if you do require a monitoring of your network performance at the edge sites that are outside of the edge compute stack hosts, you can also deploy additional nodes or ENI crawlers to be able to talk to your wireless controllers, and by either using the wireless controller APIs, so from Cisco wireless APs, wireless controllers, Aruba wireless controllers, so forth. It can detect anomalies that are going on in your Wi-Fi network as well, along with grabbing the logs from the wireless controllers, and then be able to detect, again, anomalies. What it does is it actually, based on the data collected, it'll build a baseline over time and then alert you when there's an anomaly. So for example, maybe you have an event where there's lots of DHCP requests going on or something that's outside of your baseline, then it will alert you on that as well. Additionally, it also does inventory, so it's able to recognize the MAC addresses of IoT devices and then provide you an inventory view of that as well. Okay, So now kind of go into networking a little bit. So we talked a lot earlier about, oh my gosh, you have the VMs, you have the TKG, and you have TKG workload and workload clusters and management clusters, so forth. So, what does that really mean? What does it mean when you deploy it? And so what we mean is this is kind of a recommended starting point if you're deploying all of this infra in your data centers. So you should at least have these 6 VLANs or networks that are created. So one for management, another one for vSAN, vMotion. If you need them to be separated, based on your requirements, you would do that as well. So that will be additional 2 networks. And then there is a TKG management VLAN for your TKG management cluster or control plane, and then the workload VLAN as well for your workload cluster. And then at last, if you have other VMs, things like load balancer, inbound load balancer you have to deploy that you want to isolate from your Kubernetes networks, then you would want to just put it on a separate network, right? And I just call it data in this case, and it would just be traditional, say that, but just be VMs and other infrastructure that you want to deploy in that network, right? So this is kind of minimum you want to start with if you're deploying something from scratch. And this is looking at it from more of a networking perspective. So those colored boxes that are in the middle reflect the VLANs we just talked about in the last slide. And then we're saying for a data center side, where you have minimum of 3 hosts, likely 4 hosts, you cannot connect the hosts back to back, right? As opposed to a 2-node cluster we'll talk about next. So you'll have to connect everything to your upstream Tor switch, and this is kind of a reference for how you would want to deploy that. Specifically, I want to call out here is that this, I see customers don't really leverage this very often, but for redundancy and failover reasons, it's highly recommended that, if you have 2 NICs that are available, outside of, or 2 or more, definitely, you would want to put them in a link aggregation protocol together, in the LACP or lag or ether channel, whichever term you like to prefer. You want to put them in a lag, and then you want to trunk all of your VLANs, like let's say in this case, 5 or 6 VLANs out of that, the same, all of those, however many interfaces you want to put in a lag. So you can configure them to be failover of each other, so active, standby, active backup or standby, or you can have them all be active at the same time, right? So it's going to use those links all together. So how you do that is in your port groups, you would want to configure NIC teaming inside of the port groups in VDS, and then on top of it, at the vSwitch level, you want to create your LACP, right? Your ether channel or port channel to link those physical NICs together. Okay. Similarly, you want to do, this is for a edge site. So the management, depending on how many apps and how much workload there are at that particular edge site, you don't need, right? Maybe you don't need to segregate those VLANs. You can consolidate the management and let's say the vSAN and vMotion in one. Not that I would recommend it, probably definitely separate management from everything else, right? So you want maybe management and vSAN, vMotion in a same network, and then your TKG workload cluster and the VMs. If you don't have a whole lot of segmentation needs at your edge sites, then you can consolidate them in a single VLAN. Okay. So this is what we recommend for a 2-node edge design, and you'll notice that in this case, right, there's an extra line that's purple kind of in the bottom there that's going between the hosts. So what we mean is for a 2-node cluster, the recommendation is you want to use vSAN, you want to connect the 2 nodes back to back. So if there are 2 links that are available, you want to connect them back to back, and then basically enable lag between them if you want to, or for just depends on how much bandwidth and you need there. And one of the really good reasons to actually connect them back to back is that at your edge sites, because vSAN has a 10 gig requirement, you may not always have a 10 gig, 25 gig switch there at that edge site. So, what we hear from customer is that they didn't realize they can just connect them back to back and not needing a 10 gig or 25 gig switch at that site. And again, when you talk about cost of a 25 gig switch across hundreds of sites, it's quite a bit of savings there as well. So in this case, you can actually leverage a vSAN witness that's a shared vSAN witness that's in a data center, right? So that's actually a VM appliance right now as we're speaking for 7.0 and 8.0. So you can deploy a VM appliance for the vSAN witness that's in a data center, and depending on the size that you configure it, it can support up to 64 clusters per appliance. So obviously you want to do that math ahead of time as you're planning for your deployment. Okay, so here's a design that I'll probably spend quite a bit of time here for a Dell XR4000. So that's a platform we've seen quite frequently from customers requesting, hey, how do we do this on the XR4000? So what's special about the XR4000, which I think is it's pretty cool for a edge use case, is that it's got the 2 nodes that you want to run your workload on, right? On the lower left there, it's all compacted in a single. It's not even 1U actually. It's a fairly small box, and then there's a witness blade that's local at the site there. So that's I think highlighted in red. So that witness is just an Atom-based EXXI host, and then inside of EXXI host you have a vSAN appliance VM that's running there, and that vSAN appliance VM is acting like a third host, right, for quorum purpose for vSAN. All right, so and I think it's a great platform because again, it's small and it's everything kind of compacted in one, delivered to an edge site. It's easy, right? And then second thing, like we mentioned a little bit earlier, is that you don't require a 10 gig or 25 gig switch for vSAN using this box. So I kind of drew the little blue and purple connection between there, meaning that you can literally connect the 2 hosts back to back, right? Okay, I think that's pretty much all we want to cover in terms of just high level there. And then on the right, I kind of talked about, okay, how would you want to design it from a networking, just IP addressing standpoint? So the connectivity that are required here is that there should be a network for witness traffic essentially, and that can be configured on the same VM kernel as management as well on that rightmost witness appliance. So if you don't want to separate the witness traffic and the management traffic, you can actually use the same VM kernel for that. And you just need connectivity from whichever witness traffic VM kernel on the data plane nodes, right? That they need to be able to talk together. So in this case, I have them separated, meaning that there's a separate network, 192.168.15.x there for the witness traffic, and that's separated from the management network, right? And so in this case, witness traffic, vSAN, vMotion are all local networks to that specific edge site, and there's no need to propagate those networks to the rest of your enterprise, right? Meaning they'll just stay local, everything's local there. So in this two-node design, if you're looking at Kubernetes or specifically TKG workload clusters that are deployed there, one thing to note is there's no need to create 3 control plane nodes in this case because you only have 2 nodes anyways, and you can't really meet the etcd quorum requirement, right? So the etcd is a database used in Kubernetes, and it requires 3 nodes minimum for quorum purpose. And so you would just deploy, like if you were deploying your clusters on the 2-node cluster, you would want to deploy it with a single master node, control plane node, and then 2 or more or however workload clusters workload VMs that you need to deploy. So these are Kubernetes clusters. They're running inside of a VM essentially. So in that case, you just deploy however you need, and then you let DRS and HA take care of which node that you want them to run on. This is just a summary of kind of everything we talked about. If you don't have a local host as a local witness host, and you want to use a shared witness appliance, then these are the minimum requirements you have to meet. Specifically, the largest VM appliance support up to 64 Wright clusters, and then the round trip time you need, from latency perspective, from your data plane node at the edge to the shared vSAN witness is 500 milliseconds round trip, and that should be, I think, more. I mean, I really hope all your environments can have less than 500 milliseconds latency from an edge to your data center, right?
Some heads are shaking.
Unless it's over satellite, so.
Oh, okay.
Good point. So the comment was that, there might be satellite or military use cases where they would really have to test and make sure they meet the requirements. All right, so I'm going to hand it over to Mike now for the Edge app delivery, and then we'll kind of conclude with Edge use cases and a little bit about GPU support on on Edge Compute Stack, or specifically vSphere, and go over question and answer, Q&A.
Cool. Yeah, so this next section is going a bit deeper into the app challenges. And, like we see the same app challenges for Edge developers that we see in data center. And namely, the most prominent one is just the complexity of Kubernetes itself. So yes, there may be legacy VM-based apps that are being delivered by COTS, but if you've got developers, typically nowadays they're building those apps and deploying them to Kubernetes. The challenge with Kubernetes itself is that, well, it's kind of like an ESX where it's got 1,000 knobs and lots of knives in the drawer to cut yourself with. So if you wanted to staff a team of Edge developers that can be productive on Kubernetes at the edge, you probably have to get the experienced developers that cost a lot more than like a Spring developer that you might get that's only got 4 or 5 years experience. So how do you address the complexity, the requirement for very advanced skills to be proficient at Kubernetes at edge? Well, there's things that can be done to reduce the complexity or make it easier with the concept of golden paths, and that'll explain as I go through this. So those challenges exist even with data center as they do with edge. So VMware builds a platform called Tanzu Application Platform. This isn't included with ECS, but it's something that works quite well with ECS rolled out to edge. So you'll see lots of sessions, at the event about Tanzu Application Platform, but essentially it is kind of that end-to-end developer portal where somebody can come in and go to a portal and find example apps of something similar to what they need to develop, where they just pull down those accelerators as that golden path, and it basically implements the full CI toolchain with sample code and documentation to go with it that meets the patterns of what your top architects define as the approved patterns for edge. So it is a portal for developers to learn and get started really quickly without hitting the wall of YAML that you get with Kubernetes. So it's got onboarding, it's got compliance controls. You're basically controlling the guardrails for developers bringing apps to cloud or data center or edge. And it also enforces security into the pipelines by default. This concept of scanning the code and then scanning the resulting containers, building those containers automatically, that's something you'd have to turn off in Tanzu Application Platform. And so that works quite well with edge because in data center, developers are iterating, building apps. The platform creates the containers. Developers don't create Docker files, so you have a lot of control over the contents of that container. The other nice thing about the way it creates those containers is it splits up that container into layers, and that layer would be made up of the code that the developer wrote, the runtime, whether it be Java or Node.js or something like that, and then a base operating system for that container. There's a few other layers in there, but what that means to Edge is that when I update my application with that approach, if nothing else changes, then the only thing I have to ship over the wire is the layer that the developer changed to 1,000 sites. So when we trigger this GitOps approach to say that version 2 of application A has been delivered, we don't have to deliver that full 1 gig or 500 meg container image to thousands of sites. It's really just that layer of that container that was changed. And so that whole process can be controlled through GitOps. So that happens with Tan's application platform, and then we manage the GitOps process that is driven by Flux, technology called Flux CD, a very lightweight GitOps engine that can run in your Edge clusters. And we manage that through tons of mission control. So that's where the two sides of app platform and mission control come together for Edge, is in your GitOps Git repo and delivering that out to your Edge sites. And so that's where you can group these clusters into different regions, for example, and you might organize your Git repo, your GitOps Git repo, into branches specific to a region. So each region mapped to a group in TMC can point to a branch on a specific GitOps repo, so that you can control sets of rollouts of those updates to those applications. And again, take advantage of the layered container. You might optionally run a Harbor. Harbor is the registry, open source registry from VMware. You might optionally deploy that at Edge if you've got enough resources, so that you can carefully stage those container updates first, and then trigger the GitOps process once that's arrived over the network, however bad that network is, and trigger the update of the application from a local registry instance. That's optional. We do have some customers that they want to stage their container images first at the Edge site before they trigger it, because they have issues with network connectivity and transporting those container images over spotty networking. And so this is kind of walking through that example a little bit more. Let's say, for example, you have an app called Computer Vision, and you want to manage the delivery of that to thousands of Edge sites. First, I would create a GitOps branch for each one of those. Each set of Edge sites I want to group together. I'll create a branch in the GitOps repo. Next, I'll build, test, scan, publish the app, and deliver the GitOps YAML needed to deploy that to a main branch, and a human would promote it to a GitOps branch that a set of clusters would be ready for. So you could either have this fully automated through to your different branches, or you have a human step to approve that release to a set that you want to roll that out to. But you can control that with your whatever Git technology you use on-prem or cloud. And then organize your Edge clusters in that same format. If I've got prod region 1, I'm going to have 100 clusters in prod region 1. I'm going to have a branch called prod region 1. And I'm going to set up a GitOps trigger flow for that group of Edge sites. And so whenever there's an update to the app, then I trigger that for that specific branch and that specific set of clusters. And like I said, this is probably not a joke for some. Roll out your prod updates to the sites that are closest to headquarters, because if something goes wrong, at least you have the chance that you could drive there and take a look at it. But hopefully you have that opportunity in your Edge sites. Okay, so getting past that, now we're getting into some of the improvements since last year that a lot of our customers have been driving for our standard ECS stack with Kubernetes. So as a result of customer requests and requirements, we now support this concept of a single node cluster. All that really means is, if you're familiar with Kubernetes, you have control plane nodes and worker nodes in a cluster. This collapses that to a single VM, where it's both a control plane node and a workload, and it gives you the API and kind of a deployment topology for maybe a handful of containers. So that's an area of where we've kind of shrunk the architecture. That was one of the improvements since last year. kubevip, load balancing with kubevip. We do have a lightweight load balancer, and we also support metal LB. And then IPAM for workload clusters. Before this, DHCP would be a requirement at the edge site to use TKG, because the VMs would have to come up and get an IP address from some service there. Some of our customers don't have even a DHCP service at the edge site, so this allows you to manage the IP assignment in the framework itself. And this kind of giving you some of the details. You know, the way TKG works is you describe a cluster the same way you would describe an application deployment for Kubernetes. It's, you know, basically a YAML definition that says, here's what my edge cluster looks like, and here are all my settings, and then you store that in a Git repo. So if you needed to update or provision a new Kubernetes cluster, you just drive that from a Git process, GitOps process. Okay, so that was a little bit of some of the fine tunings that we've done for Kubernetes at the edge. Now we're getting into use cases, and we'll talk specifically about GPU.
Yeah. I feel like we're doing a cuts by 1,000 slides here, but there's just a few slides, and hopefully we'll end up with some very interesting use cases, and then Q&A. We'll leave about 15 minutes for Q&A. So yeah,
even though edge is small, it doesn't mean all the complexities that you run into data center completely go away. You have networking, you have storage, you have compute, you have security, just all in one little box.
Yeah, so I think this will be a theme you'll see in some of the edge sessions for the rest of the week, right? And so it's a very verticalized solution, meaning that we basically the Edge Compute Stack is there to support these different application use cases. So for retail, it's really more around fraud detection and around AI and inferencing. And then for the verticals in like manufacturing is really about supporting these, we call real-time applications, right? I think I talked about a little bit earlier is that you have OT applications that require Profinet, like a virtual PLC or I/O devices, and to support those, you need real-time switch in this case, and also ability to be able to interact with the virtual PLCs either by supporting things like discovery protocol, DCP in Profinet, as well as support, like be able to communicate LLDP and support SNMP and those kind of things.
Yeah, so I guess some of you are in industrial situations, environments. You probably know that traditionally workloads that require real time were never really targeted on virtual infrastructure because of that strict requirement around the real time. You can't have a robot that pauses because something's doing garbage collection and then continues. That's what we mean by real time. It's got to have predictive, responsive cycle times in the software. And traditionally, they've avoided virtualizing that type of software because of the jitter that you would see. Now we have the opportunity to run those real-time workloads without the jitter that Ken was mentioning.
Yeah, and it's literally down to microseconds. Like we're talking about safety PLCs that require under 100 microsecond of jitter, right? So yeah, right now with real time, like when you go into your VM right now, there's an option under advanced that says high latency sensitivity. When you check that box, and then along with another box, you'll have to reserve memory and CPU for real-time applications. So that's one way to enable it right now. We'll make it easier in the future to do that. So we'll just kind of give you example of what we're talking about. Oops, sorry about that. Similarly, I think in the utility space, right, in a power utility space, that's a similar use case there as well for those applications that require consistent, deterministic, low latency behaviors. So I think it's a theme here, right? It's a very verticalized solution, and we're talking about enabling computer vision at the edge. We're talking about supporting Kubernetes-based applications at the edge, and then we're also talking about edge compute being used for these real-time applications. And the video is just a snippet from Hanover Messe, which was in April earlier this year. and you have the application used for that running on Kubernetes in this case with real-time characteristics. Okay. All right, so this is currently a roadmap, kind of a roadmap feature that we're building for the vSwitch, is the ability to support Profinet and support PRP initially, right? So there are many different OT applications like Modbus, and I'm sure many of you sitting here can tell me a lot more about those different OT applications and how they behave. But for real-time networking challenges for these applications that under 1 millisecond network latency is actually pretty high in those environments. And then like I mentioned earlier, to support the virtual PLCs, you have to support these additional protocols, right? And so what does that kind of high-level architecture would look like, right? So from there, you would have a cluster similar to how you would support these different virtual machines and the TKG workload clusters. It's just that for the vSwitch, or in this case, the virtual distributed switch, we're going to enable these supported OT protocols in them, and it's going to be based on the enhanced data path of NSX. So if you want more details about this, you can come talk to me at the expo. I'm going to be there for the rest of the week, and we can actually show you a prototype of how we demonstrate that. So again, it's kind of repeating myself now. It's about Profinet support. It's about PRP support. So if you are familiar with OT protocols, PRP is one of the requirements, right, to be able to kind of replicate a packet between virtual PLC and I/O devices across two different networks. And then basically whichever one that makes it to the other side will be used, and then the duplicate one, if it gets there, will be discarded. So that will be supported in the real-time vSwitch. So why do we want to do this, right? And the reason is that today in manufacturing, on the manufacturing lines, you typically have multiple boxes that are doing specific functions. So, the PLC being the highest value device that are on the manufacturing line. So it's typically like a Siemens or Phoenix Contact or Codisys PLC run, it's a physical device there, right, connected to the various IOs that are controlling robots and other things on the manufacturing line. And then you would have another box that's like IPC running a HMI, human machine interface, right, for interacting with engineering programs or interacting with that PLC. And then you would have another box potentially for computer vision. So what we want to do is by enabling you to virtualize the PLC, which is the highest value application running in these lines, then you can consolidate that along with all of these other applications that are on the floor, right, and consolidate them into the Edge Compute Stack. That could be multiple clusters, and then you can put all of that inside of a single, let's say, closet. And then what that does is it would really streamline your operations, improve security. Now you can do automatic patching for these virtual PLCs and HMI applications and so forth, and then just overall increase your productivity, right, at the facility. Okay. Right, and the last really slide I have for use case is for the retail use case, and really this is really around around computer vision in this case. I don't know, Mike, if you want to.
Yeah, I mean, just like we keep saying, it's one of the hottest topics, notwithstanding retail, but there's obviously a desire not only to do retail fraud prevention, but also look for spills in the aisles, to look at what's happening at the scan checkout, maybe even recognizing certain individuals based on opt-in on loyalty programs and things like that. So there's all kinds of use cases for retail, but then also there's retailers that have small, medium, and large stores or retail locations. They might have sort of express type locations, and they might have, let's say your big box grocery environments. And so we want to be able to support all those use cases in as many of the edge footprint profiles as we can. And so we have to not only work with the software that runs inside these environments, but also the various forms of accelerators, whether it be NVIDIA GPU or Intel iGPU or TPUs or you name it, there's all kinds of accelerators, and then there's different AI formats that folks are starting from to train their models and deliver them to the edge. You know, you might start in the data center on something that requires CUDA, which is an NVIDIA, hardware-based environment, but you're targeting a small Intel device that you don't have, the budget for thousands of NVIDIA GPUs. How do you take that from that data center modeling environment, convert it to something that can run well without an NVIDIA GPU on an Intel environment? So in retail, that's one of the challenges we have in supporting all the permutations of whether it be these larger edge stacks with NVIDIA GPU down to smaller ones with TPUs or iGPUs, accelerators embedded inside them. So GPU deployment on edge. First, we've got lots of great examples of automating the discovery of different accelerators, especially NVIDIA. We've got a specific partnership with them where you can virtualize your GPUs. So if you do have a lot of edge workloads that require a GPU, one of the challenges is having the ability to share that GPU, do time slicing sharing of that one expensive piece of hardware. So working together with NVIDIA, we can slice up those GPUs into virtual GPUs so that you can have multiple, let's say COTS delivered solutions running on that same compute stack with maybe one GPU, NVIDIA GPU. So that is an option with ESX, is taking the NVIDIA GPUs and breaking them up into virtualized. Pass-through is, like it says on this slide, pass-through is still an option. The one footnote about vGPU is that does require a little bit of additional software from NVIDIA along with ESX to run as a virtualized GPU. But pass-through we can automate through to VMs and also automate it through to Kubernetes workers. So if it's a TKG worker and you've got a container that needs GPU, we've got the automation to provision those clusters so that PCI pass-through can also be leveraged in those environments. But in that case, you have one worker per PCI pass-through device in that case. There's software that can be added to Kubernetes to break up the time sharing of that GPU at that level. But for worker VM, we can only have one assigned to one PCI pass-through GPU.
Yeah, so the main thing really to note here is vGPU requires additional licensing from NVIDIA, right? So NVIDIA AI Enterprise, and then for pass-through, or sometimes it's called Direct Path I/O or Dynamic Direct Path I/O, which is enhanced features in 7.0 to support, HA and initial DRS, initial placement for DRS. So for pass-through, there's no vMotion and load balance DRS support in any of the EXXi versions right now. So just be aware of that when you use that. And so here's some of the best practices when it comes to that, right? So we're giving you an example here. Let's say you have a server with two sockets and you have multiple computer vision applications. Then what do you choose, right? At edge, because of so many sites and costs involved, do you choose pass-through or dynamic or direct path I/O versus vGPU? And so these are things, right, you want to be aware of, is that most GPUs are full height and full length. So like anything above, I believe 830, let's say for NVIDIA, those are all full height and full length GPUs. So you have to be aware of how many PCIe slots you have in a server. And then so the costs involved, if you look at the costs that are involved with using vGPU, I think, we kind of can summarize down that if you have more than 4 CV apps coming from different vendors, at the edge, then it's probably more cost effective to use vGPU, even considering the licensing costs involved. And then if you have anything less than that, if you just have a couple CV applications, then you would just use pass-through or dynamic direct path I/O. Right, so this is a slide for best practices and key takeaways. So we're going to, you're going to get these slides from, from the event afterwards. So we're not going to go through them one by one, but the point is, I just want to highlight really is make sure you have the edge from a management perspective. You want to separate your edge cluster management, differently from your data center management, and then leverage VDS, and then from ASP perspective,
obviously the theme of automate everything with GitOps and take a minimalist approach to HA if you can. In fact, even in the case of disaster recovery for an edge site, if you can favor the edge repave versus edge repair attitude, then you'll save yourselves a lot of money per edge site if you approach it that way. And by edge repave, I mean treat every edge site as ephemeral. And yes, there might be important business data that you're pumping off with a store and forward type of a technology. If you can put up with a little bit of data loss, then you probably can build a process around edge repave instead of this DR backup restore type of approach that we see in the data center. And that can keep the cost significantly lower. And when it comes to state, use a data service that has edge to cloud technology. That way you might be able to avoid some expensive storage technology if you rely on a data service that just kind of takes care of the data for you and gives you a way to propagate it off over a WAN connection.
That's it.
Yep. All right. So that was a lot of ground to cover. If anybody has any questions, question.
Question for the shared storage. The use of vSAN at the edge. I mean, we have a use case where we believe the vSAN is too heavy for the edge because of the overhead.
Yeah.
Even with ESA, it's still a bit heavy. So do you guys are thinking about a lightweight storage solution for it?
As an alternative to vSAN, I wouldn't say we're looking at another clustered storage technology, but I would say kind of like what I was alluding to there, the alternative would be if you can change the architecture of the app so that state, if you don't have control over the app, then I guess if you have to rely on shared storage, then I don't think we're looking at another storage technology.
So when you say vSAN is heavy, so the question to repeat for everybody was basically, vSAN seems to be a bit heavy for edge use case. So what's the recommendation there? So when you say heavy, do you mean the memory requirement of vSAN is heavy or the storage requirements?
Yeah, you need a certain amount of drives, the capacity of the drives, and there are some requirements.
Yep.
The number of vCPUs you need to handle vSAN.
Yep.
The memory you need to handle vSAN. At the edge, we're talking about vCPUs, right? You don't want the vCPU is meaningful.
Mm-hmm.
So vSAN will take some of that.
Yeah, that's a really good question. Yeah, we're actually I can't remember the exact format. I think they call something 3 right now, which is the smallest ESA ESA architecture that's allowed. I think I'm going to say it's I forget how many terabytes, but we are working with the vSAN team on an even smaller footprint for vSAN that will require less storage and less CPUs. Okay.
And you don't, this is a COTS application, it's not something you develop in-house?
No, it's a third party.
Third party. Okay. Yeah.
Just give you a use case.
Yeah, so the smaller form factor we're talking with the vSAN team, they're talking about around that 1 terabyte kind of storage requirement. And I'm going to say it's 4 vCPUs for vSAN requirement. That's what's on the roadmap right now. But definitely if you could come talk to us afterwards and Yes.
Firstly, the whole question of centralized versus decentralized. I work with customers where sometimes central vCenter is central TKG is great. That's a big chunk of unit. You use that often, but the vCenter is a solution number one. And also IT/OT convergence, you want the IT and IT workloads on the same cluster. You're also looking at NSX, whether it be
Using NSXT, or you were saying? Yeah.
Running on the same network segment
Yeah.
Yeah.
as the IT
Yeah.
provides, so some way a bit more partitioning.
Yeah, if your edge cluster is beefy enough, and NSXT and even NSX Advanced Load Balancer, they're not optimized for small spaces. Yeah. So maybe we could check with the NSX team to see if they're looking at shrinking some of that. But as far as it stands right now, the best answer would be potentially if you're running in Kubernetes and you're using something like Entrea, that does have the ability to do segmentation inside Kubernetes clusters if you could go that route, or separate altogether VLANs if you've got different workloads. But it's kind of a manual approach rather than something that's automated. Yeah. So vCenter, I'm not sure where we're allowed. There is roadmap stuff going on with vCenter to shrinkify and localize the capabilities, some of the capabilities. We do have a lot of customers that are already running vCenter in their data center and connecting out remotely to ESX hosts. And so that's been in operation for quite some time, but there is some areas of improvement for the TKG component if you've got long outages from the edge site. I would say probably when we get to those localized vCenter services inside the cluster, then we're going to be able to do fully autonomous failure recovery in the case of connectivity loss. Yeah, there is some limitation in failure recovery scenarios if both the network goes down and you lose a physical host at an edge site. We call that a double whammy.
Yeah, so actually you read our mind, I guess. With Edge Orchestrator, like the VECO, I chuckle sometimes when I say that. It's with Edge Orchestrator, a localized slimmed down vCenter is one of the things that are on the roadmap. So it's not in the slide because obvious reasons, but yes, that is something that's on the roadmap.
Yeah, but if you lose connectivity to vCenter in the data center, everything is going to run fine. It's only when you have another kind of problem while that connectivity is down, that's where there's some limitations in what we can do. Because there's some steps in the process that rely on that vCenter to do a sort of a recovery from.
One quick question. Your joint venture that you've got going with Siemens and Profinet and so forth, have you got a roadmap with other industrial protocols or any other kind of partners you're working on in that space?
Yeah, we're currently working with Siemens and Constant Contact and Constant Contact and Codesys. Those are the three PLC vendors we're working with right now, and initially we'll support, I think it mentioned in the slides, it will be PRP and Profinet to start. In terms of other OT protocols, that has yet to be discussed at the moment, but yeah, we'd love some feedback on that. Yes?
Does ECS, is it looking at any kind of a more efficient templating? What content libraries is currently able to do?
You mean for distribution of VMs, VM templates?
So, sounds like you're doing a lot of great work, around this area for containers.
Containers, yeah.
What about my VMs that I can try to push down?
Yeah, it would be nice if we could build VMs in layers and only ship deltas. Yeah, I don't know of any work that's being done in content libraries.
Yeah,
that
I
can think
am
of.
not aware of that either at the moment. Yeah, but can you just so we could understand what is the use case there? So if you could
Basically, what I described for containers, you'd like to see that for VMs.
You could just set up a management. So, I have 700 stores that my facility operates in. Just setting up 700 content libraries and trying to pull that down. Most of the time, it just never succeeds. Never were able to do that. By the time it was done, same thing. We had the next image queued up ready to go. So we ended up essentially having to write our own based on RC, I think.
Oh, yeah.
Which is working, but it
Yeah.
Yeah, I would.
I like the idea. We should probably, that's feedback we should generate and get everybody excited
for
about
our
and then
core
take it to
team.
them. Yeah.
Yeah. Okay. All right. Thank you guys very
Thanks,
much.
everyone.
It is
Appreciate
literally
it.
right on the dot. So.
Thank you.
Yeah.